This diagram depicts the anatomy of the heart. The superior vena cava is one of the two main veins bringing deoxygenated blood from the body to the heart. Veins from the head and upper body feed into the superior vena cava, which empties into the right atrium of the heart. The inferior vena cava is one of the two main veins bringing deoxygenated blood from the body to the heart. Veins from the legs and lower torso feed into the inferior vena cava, which empties into the right atrium of the heart. The aorta is the largest single blood vessel in the body. It is approximately the diameter of your thumb. This vessel carries oxygen-rich blood from the left ventricle to various parts of the body. The pulmonary artery is the vessel transporting deoxygenated blood from the right ventricle to the lungs. A common misconception is that all arteries carry oxygen-rich blood. It is important to classify arteries as vessels carrying blood away from the heart. The pulmonary vein is the vessel transporting oxygen-rich blood from the lungs to the left atrium. A common misconception is that all veins carry deoxygenated blood. It is more appropriate to classify veins as vessels carrying blood to the heart. The right atrium receives deoxygenated blood from the body through the superior vena cava and inferior vena cava. The sinoatrial node sends an impulse that causes the cardiac muscle tissue of the atrium to contract in a coordinated, wave-like manner. The tricuspid valve, which separates the right atrium from the right ventricle, opens to allow the deoxygenated blood collecting in the right atrium to flow into the right ventricle. The right ventricle receives deoxygenated blood as the right atrium contracts. The pulmonary valve leading into the pulmonary artery is closed, allowing the ventricle to fill with blood. Once the ventricles are full, they contract. As the right ventricle contracts, the tricuspid valve closes and the pulmonary valve opens. The closure of the tricuspid valve prevents blood from backing into the right atrium, and the opening of the pulmonary valve allows the blood to flow into the pulmonary artery towards the lungs. The left atrium receives oxygenated blood from the lungs through the pulmonary vein. As the contraction triggered by the sinoatrial node progresses through the atria, the blood passes through the mitral valve into the left ventricle. The left ventricle receives oxygenated blood as the left atrium contracts. The blood passes through the mitral valve into the left ventricle. The aortic valve leading into the aorta is closed, allowing the ventricle to fill with blood. Once the ventricles are full, they contract. As the left ventricle contracts, the mitral valve closes and the aortic valve opens. The closure of the mitral valve prevents blood from backing into the left atrium, and the opening of the aortic valve allows the blood to flow into the aorta and flow throughout the body. The tricuspid valve separates the right atrium from the right ventricle. It opens to allow the deoxygenated blood collecting in the right atrium to flow into the right ventricle. It closes at the right ventricle as the right ventricle contracts, preventing blood from returning to the right atrium, thereby forcing it to exit through the pulmonary valve into the pulmonary artery. The mitral valve separates the left atrium from the left ventricle. It opens to allow the oxygenated blood collecting in the left atrium to flow into the left ventricle. It closes as the left ventricle contracts, preventing blood from returning to the left atrium, thereby forcing it to exit through the aortic valve into the aorta. The pulmonary valve separates the right ventricle from the pulmonary artery. As the ventricles contract, it opens to allow the deoxygenated blood collecting in the right ventricle to flow into the lungs. It closes as the ventricle relaxes, preventing blood from returning to the heart. The aortic valve separates the left ventricle from the aorta. As the ventricle contracts, it opens to allow the oxygenated blood collecting in the left ventricle to flow throughout the body. It closes as the ventricles relax, preventing blood from returning to the heart.